All right, still on coordinate geometry. We are going to discuss under it equation of a straight line. Yes, they will discuss the gradient of a straight line. Somehow we'll be making use of the same topic of yesterday, which is gradient of a straight line. Now let's see. Now the equation of the line, all right, through a point, let's say point A with coordinates x1, y1, all right, with gradient m, like we discussed yesterday, all right, in a point is given thus we have y minus y1 equal to m to bracket open x minus x1. Now one might say, how do we arrive at this point? Okay, let's go back to yesterday's lesson. Let's see, put this one on hold. We discussed that gradient of a particular what was it called, straight line, okay, is given like this: m is equal to change in y over change in x. So this implies that y2 minus y1, all right, is equal to m into bracket x2 minus x1, all right. So this is when it passes through 2 points. This is just a point, all right. If you watch, the y2 still appear here, but here just put y there, all right. The y2 is not in this first one, mean that it's just 1 point. That 1 point is where y1 and x1 formed a coordinate. Is that okay? But generally, let's put it this way: a straight line equation or equation of a straight line has this general formula, which is y is equal to mx plus c. This still has a resemblance with this, but this c means intercept. Intercept means, for instance, you plot a graph. We also have our x and y axis, right? Now when you pick those points with a straight line, the part of that straight line that touches the y axis is the intercept of that graph. Is that okay? Now this m is our normal gradient, where y and x are our variables, which is the two axes that make up the plane we always use to find points on coordinate geometry. Is that okay? Good. Now let's actually go with these two circumstances or conditions when it passes through 2 points and 1 point. Let's look at when it passes through, okay, let's say when it passes through 1 point, okay, which is this first one here. Now let's go this way. Okay, I say find or let me just say the equation for the line that's passed through this point here, which is -2 and 5, with minus 3 as the slope or gradient. Very simple. Look at this. This is just 1 point. All right. This is my x1. This is my y1. Now, what do we do in solution? Simply, we take this first formula here, which says y minus y1 is equal to m into bracket x minus x1. All right. Now, y minus my y1 is 5 equal to my m is minus 3, which is the slope, minus 3 into bracket x minus my x1 is minus 2. So if I put minus 2, that means minus time. Okay, don't worry, minus 2. Okay, now let's go. Y minus 5 is equal to, you see, this is, we have two brackets in this place, so let's clear it and have just one. Minus 3 into bracket x, minus times minus is plus, so I have plus 2. Okay, so I have y minus 5. I open my bracket, minus 3 times x is minus 3x, minus times plus is minus 3 times 2 is 6. All right, remember this equation must have this form, so that means y must be alone. So let's go. Y is equal, so to make y to be alone, this 5 must leave and come to this side. This is a constant, so you come to meet minus 6 as its fellow constant. Is that okay? So I have y equal to minus 3x minus 6, it becomes plus 5 once it crosses over. So let's go. Y is equal to minus 3x. All right, then minus 6 plus 5 is minus 1. Is that okay? So at the end, this is the equation we formed at the end of this. So you see, this has this form. Here now, my c is minus 1. My m, sorry, please, pardon me. What we got has this form. Okay, let me show you. My minus 3 here is my gradient, which is this. My c is the minus 1 I have here. Is that okay? So that is that. Now let's work with when it passes through 2 points. Okay, let me say the point through which the line passes through is, let me just say I have 3, 1 for the first point, and 6, minus 8 as the second point. Is that okay? Simply remember our formula for gradients. Okay, from there the next equation comes in. Is that okay? So I have y2 minus y1 is equal to m into bracket what, x2 minus x1. But before this, okay, let's find our m, meaning we're going to look for our gradients, which is m is equal to y2 minus y1 over x2 minus x1. That is where this formula comes from. Is that okay? Now my y2 here is minus 8. Okay, so I have equal to minus 8 minus my y1 is what here? Y1 is 3. Sorry, pardon please, my y1 is 1, please pardon me. So I have minus 1. Now my x2 is 6. Okay, minus x1 is 3. So I have minus 8 plus 1 is, sorry, minus 1 is minus 9. 6 minus 3 is 3. When I divide, I have minus 3. Therefore, my m is equal to minus 3. Is that okay? Which is my gradient. So back to this formula to get the equation that line actually formed. Is that okay? So let's go back. So I'm going to have in this place, this is what I'm going to have now. Okay, just pay attention here, very much attention. Forget about the subscripts at this point. Meanwhile, we are going to be working with these very ones, which is the what's it called, the first one, which is the x1 and y1. Is that okay? Please pay very attention here, please, very much attention. See, at this point we assume that you are working with just 1 point. Is that okay? Now that very 1 point here is what? This first point, which is this point here, 3 and 1. Okay, so I'm going to have that y minus y1 is equal to m into bracket x minus x1. Is that okay? So y here minus my y1 is 1. Okay, is equal to what again? My m is minus 3. Is that okay? My x minus x1 is what? 3. What I have here. Is that okay? So let's go. Now at this point, this implies that, let me open my bracket, y minus 1 is equal to minus 3 times x is minus 3x, minus times minus is plus, 3 times 3 is 9. Is that okay? Let's continue. Y minus 1 is equal to minus 3x plus 1. This implies that y, now at this point, let's collect like terms. Let this minus 1 cross to meet 9 here. Okay, so it becomes y is equal to minus 3x plus 9. The one minus 1 here becomes plus 1. Okay, so I have y is equal to minus 3x plus 9 plus 1 is 10. Is that okay? Now at this point we have equation of a straight line. I hope this actually solves your problem as regard equation of a straight line. Okay, you're going to expect your own exercises as soon as possible. Thank you.